Had a good intro. That was just like iconic.
An iconic intro?
You should get the graphic design just to make you an intro.
Oh, yeah.
Yes.
I should make my own intro.
That too.
Yeah,
All good ideas.
great ideas. You know what? It's a great idea that we get started reviewing this. All right, how would we do this? What rule? Chain rule. So it's 3 parentheses x squared plus 2x plus 4 to the second times 2x plus 2. And they want it at 2. So it's 3 times 2 squared plus 2 times 2 plus 4 squared. 2 times 2 plus 2. Lots of 2's. Three times 144 times 6. I don't know what that is. $2,502? 92? Okay. So really, that's a slope at 2. That's pretty steep slope, yeah. It's almost straight up. This to the 4th power, how would we go about it? What would we do? I would do chain rule, quotient rule. So 4 times x over x minus 2 to the 3rd times the first derivative of that. So the first derivative of that would be the quotient rule. X minus 2 times 1 minus x times 1 all over x minus 2 squared. Now I distributed my cubed on the outside to each one of these, and you'll see why in a second. What's x minus x? Cancels. And so we have a negative 2 here. So what's negative 2 times 4? Negative 8. So we get negative 8x cubed over x minus 2 to the what power? Well, it's to the 5th power. That's the first derivative. So that was the chain rule, quotient rule. So if y equals 4x cubed minus 3 to the 4th power, what is dy dx? 4 parentheses 4x cubed minus 3 to the 3rd times 12x squared, which is 48x squared times 4x cubed minus 3 to the 3rd power. how would we do this? I would rewrite it as the cosine of x to the 4th power. And then do the chain rule, which is 4 cosine of x to the 3rd power times what's the first derivative of the inside? Negative sine of x. So it's negative 4 sine of x cosine cubed of x. This would be what? Chain. The original is sine of 2x to the 4th power. So the first derivative is 4 sine of 2x to the 3rd times the first derivative of the inside, which is cosine of 2x times the first derivative of its inside, which is 2. So it's 8 sine cubed of 2x cosine of 2x. Implicit differentiation. What's the first derivative of 4x squared? 8x. The first derivative of negative 2xy. Negative 2x times first derivative of y, which is dy dx, plus y times the first derivative of negative 2x, which is negative 2, plus, what's the first derivative of 6y squared? (12y dy dx) equals 0. So you get the dy dx's together. So it's 12y minus 2x times dy dx. Take everything else to the other side. So it's 2y minus 8x. And then we divide each side by 12y minus 2x. What is the slope of this function at that point? What's the first derivative of 2y squared? 4y dy dx plus 6x dy dx plus y times 6 minus 6x equals 0. Product rule. So 4y plus 6x dy dx equals 6x minus 6y. So then divide by 4y plus 6x. So it's 12 if we put in the 2, 1, it's 12 minus 6 over 4 minus 12, which is 6 over negative 8, which is negative 3/4. Inverses. Find the first derivative at negative 2 if g and f are inverses, and g of negative 2 is 5, and f of 5 is negative 1/2. So what do? Well, we find 1 over f prime of g of negative 2. Which is 1 over f prime of g of negative 2 is 5. The first derivative, this, I bet it says the first derivative on this. The first derivative at 5 is negative 1/2. So if we divide, we get a negative 2. What is the value of the first derivative of g of 4 from the table below if g and f are inverses of each other? So it's 1 over the first derivative of f of g of 4. So, what's the first derivative of f? Well, what's g of 4, actually? G of 4. 0. What's the first derivative of f at 0? So it is 1/8. What's the arcsine of x cubed? Well, it's 1 over the square root of 1 minus x cubed squared, right? Well, then you have to take it times the first derivative of x cubed, which is 3x squared. Did I do that right? I don't remember, because I don't have my sheets in front of me. I'm pretty sure I'm right. No, that's on the sheet. Arcsine is the same as inverse sine. The only thing that's not on the sheet is, yes. We could put the derivative on top. It doesn't matter. Because 1 times the derivative is still that. So you can put the derivative on top, but you could also say, well, it's this. What's so funny, Lindsay? Are you sure? Okay, yeah.
Okay, wait, so what do I do? I didn't write anything down. You should put what we have to put back up because I forgot to write it down.
What do you mean?
Wasn't there something that wasn't on here that we were supposed to put on here? More
That.
than that?
No, I think just that.
Okay. Anyway.
So then it's 3x squared over the square root of 1 minus x to the 6th power. I think that's what the answer should look like.
So if it's anything more than x, and multiply it times that derivative.
So our cosine is negative 1 over 1 minus 2x squared within a square root times the first derivative of the inside, which is 2. So the final answer would be negative 2 over the square root of 1 minus 4x squared. Arctan is 1 over 1 plus 3x squared squared times the first derivative of 3x squared, which is 6x. So it's 6x over 1 plus 9x to the 4th.
How many questions are there?
16. I thought I said 13 too, but then I looked this morning and it's 16. There's 14 on Khan Academy and 16 on this one. Okay, how would I do this? Well, simply the inverse sine of x is 1 over the square root of 1 plus x squared. What? 1 minus x squared, yeah. And then this, 4x to the 1/2 power, so half of 4 is 2x to the negative 1/2, which is the same as the square root of x. If we leave it like that, it's just fine. It's multiple choice, so I think they leave it like that, in other words. Second derivative. Okay, this will test your metal a little bit more. This is really 4 sine of 1/2 x. Not the inverse sine, just normal sine. Okay, so what's the second derivative of that? Well, the first derivative is 4 cosine of 1/2 x times the first derivative of the inside, which is 1/2, or 2 cosine of 1/2 x. That's first derivative. That's what dy dx is. Now the second derivative, you take 2 times negative sine of 1/2 x times the derivative of the inside, which is 1/2. Well, 1/2 of 2 is 1, so it's negative sine of 1/2 x. Is the second derivative. Let's find the second derivative of this. All right. So it's 2x plus 2y dy dx equals 0. So 2y dy dx equals negative 2x. So dy dx equals negative 2x over 2y. They cancel. So dy dx equals negative x over y. Now let's do the second derivative. The second derivative of this is the quotient rule of this. So it's y times first derivative of negative x, which is negative 1, minus negative x times the first derivative of y, which is dy dx, over y squared. So it's negative y plus x, because minus a negative is plus a positive, times negative x over y squared. Now at this point, instead of simplifying it anymore, we've got numbers that we have to put in. Might as well just put the numbers in now. So it's negative 6 plus negative 8 times the negative of negative 8 is positive 8 over 6 all over 6 squared. So it's negative 6 minus 64 6 over 36. Something doesn't look exactly right here for some reason. Because I thought it would be a positive number. Well, this is negative 36 over, or negative 36 over 6 minus 64 over 6 over 36, which is negative 100 over 6 over 36. You multiply by the reciprocal. It's negative 100 over 216, which is negative 50 over 108, which is negative 25 over 54. I think that's all the way we can go down. Now, if I made a mistake on this, how could I do it on my graphing calculator? Well, I don't know if I could do, second derivative of that is concavity. So that might be right, actually. Negative 25 over 54. Because I can find the first derivative, but I don't think I can find the second derivative on my graphing calculator. Because my first derivative would be a positive number, which would make sense. And it's becoming less positive. So that may make sense that it's a negative second derivative. So, yeah. I think we're stuck like that. And I think that's probably the right answer. All right, this one. I don't think we had one of these. on your Khan Academy, but AP brings it in, and we should be able to do this. Inverse cosine of 4x squared plus y squared. First derivative of that. Well, inverse cosine is negative 1 over the square root of 1 minus 4x squared plus y squared squared times the first derivative of this, which would be 8x plus 2y dy dx. All right, so I am thinking that could possibly be the answer, but I'm checking just to make sure. Oh, I left part of the problem off here. No wonder, because I thought this looked a little odd, but yeah, that is correct there. So what you'll see on your test would be this. Find the first derivative of that. It looks similar to this. So what would we do? Well, we'd go 1 or negative 1 over the square root of 1 minus 3x squared plus minus 2y squared times the first derivative of the inside, which would be 6x minus 2 dy dx. Equals, what's the first derivative of 4 over x? Well, we can rewrite this as 4x to the negative first, right? Which is negative 4x to the negative second, or negative 4 over x squared, plus 3y squared dy dx. And we just stop right there. We want to try to solve for dy dx. Because we're just finding the basics of the first derivative here. Okay, so that's kind of what your test will look like on Friday. So you need to come in here and be ready to go right away, because we'll get started right away so you can get it done in 45 minutes. You're pretty sure you won't be here. I think around 9 in the morning. Mm-hmm. Yes, Christian.
So when are we supposed to be, like in December?